Today we're going to look at the Odin programming language. It's a mix of a lot of other languages together, but it's really nice, it's fast to compile and simple. I'm going to assume that you've programmed before when I go through this, so it'll be a little bit fast. Let's start with looking at how to print things. For that, we use this fmt package from the standard library. We say fmt.println. I highly recommend that you add in the Odin language server support here. That's what gives me all this autocomplete. To print a string, we have to use double quotes. So I'll say hello world. To run this, at the bottom, we say Odin run, then the name of our file. This is main.odin. Since it's only a single file that we're running, we have to say -file. And you can see that says hello world. This is similar to Python's print function where you can mix and match types together, separating with commas. So if I run this now, which I have set up on a hotkey, then you can see it prints it out just fine. And I didn't have to put the spaces in here because it adds them automatically. And if you're familiar with C, then you can do printf in that style. Let's mark printing as done. Next up, here's variables. There's a few ways you can declare variables here. Let's say I want to make an integer x that has a value 5. I can say x := 5. You only use the colon the first time that you're making that variable. So later on, I could say x = 8, and that would reassign the value. You'll notice when I hover over this, it says x is an int type. If you want to specify the type, you can say y:, and then you give a type. There's i32 or i16 or i8, or you could even do floats, which is f32 or f16, for example. I'll say it's just a generic integer, so I can say int. I'll say it's equal to 12. You can also just declare a variable but not give it a value, and it works fine. So I can say z:f32, which is a float 32. And then later on, I could say z = 5.2, and it already knew the type. If I didn't put this, the default value is 0.0, and for ints, it's 0. Pretty standard what you would expect the 0 value to be. We can also assign more than one value on a single line. For example, say a, b, : equals 5 and 16, and we have 5 and 16. We'll come back to this later because we can have procedures or functions that return multiple values. Since I missed this earlier, you can also have constants, which by convention you name with uppercase. To name a constant, you use the double colon, similar to when you make a function, and you can optionally put the type between there. But as long as you have the colon, then it's a constant. So if I try to change this later, you can see this is a compile error because you can't assign to a constant value. Whereas if it had said this, now I can reassign to it. This is mainly so you don't trip up and reassign the value of a variable that you didn't mean to. Let's mark variables as done. Let's take a look at if statements. Is happy, and we'll set that equal to true. So you can have booleans as well here. I can say if is happy. This is one thing I like about Odin compared to, let's say, Zig. You don't need parentheses, which is really nice. Now I can say fmt.println, we are happy. We'll run that. But if I set this to be false instead, you see we get no output. As you might expect, we also have else statements that we can attach here. In that case, we can say we are not happy. Pretty standard. We also have the else if clause. Let's say I have a : equals 5. I can say if a is greater than 5, case 1. We say else if a is less than 5, case 2, and else case 3. Pretty standard. Because we're exactly 5, we hit case 3. But if we were 8, it's the first one and the second one. Pretty standard behavior if you've ever programmed before. One cool feature that we have though, I can declare a variable inside the if statement condition. So I can say if a : equals 4, then we put a semicolon, and then a is less than 8, then do something. This is kind of a silly example here. You would probably want to call a function here instead, but just to show this works. But if I had set this to be some large number, doesn't run. This is similar to Go if you've used that before. Let's mark if statements as done. Next is loops. We have a few nice ways to write these. Let's just say I want to loop from 0 to 10. So I want to repeat something 10 times, that is. I can just say for I in 0, ... So I want to go less than 10. I can do the less than sign 10, and I'll run my formatter. There we go. And run this. You can see we print 0 to 9. If I want to use inclusive bounds instead of the less than, I can just put an equal sign. And you can see we ended on 10 after we printed all the other ones. You can also use C-style for loops. For those, it's for I : equals 0, semicolon I less than 10, semicolon I plus equals 1. We don't have the plus syntax here. Run that. The same before as when we did the exclusive upper bound here. We specify the starting value, the condition, and what we should do at the end. I assume you've seen these loops before. So if I just change this to be less than or equal, then we get everything up to 10 inclusive. When we use this C style for loop, now we can do the reverse. So if I go from 10, as long as I'm greater than 0, then I can say I minus equals 1. This subtracts 1. So if we run that, see we go down from 10 to 1. Or if you want to get 0 inclusive, we can do that. If you're familiar with other languages, you know about the while loop. Well, we don't quite have that here. Like while is not a keyword. Instead, it's still the word for. But you can just put a condition. If we want a similar setup to the normal for loop, we can just say I colon equals 0 for I less than 10, I plus equals 1, same as before. Again, you can have any Boolean condition here. If you want the equivalent of while true, you can just say for. If I run this, it's an infinite loop, so I'm going to kill it here. We can also loop over a string. For example, let's say some text is equal to hello. I can say for a letter in text. You can see that prints out each letter individually. If we want to look at the type of this, we can say type of. We say type ID of, and then type of. So you can see it's a rune. This is kind of similar to char in other languages. It basically just means a single letter or symbol of some kind. If you want to get the index and the letter, we put the index variable after. So I can say letter comma I. We can go back to letter and I. So you can see H is position 0, then position 1 is E. So it's kind of similar to Python's enumerate, except these are swap the value and then the index. Let's go back to this version for a second. If I want to go through all the letters in reverse, I can say hashtag reverse. Then we try this again, and you can see we went OLLEH. If I add in the index now, you can see that also gets reversed. We can turn this into a slice. This is similar to the Python and Go syntax. We put square brackets and then colon. So let's say I only wanted to look at everything after the first character. We can do that this way. You can see H is not here. Because what we're iterating over is now 4 characters instead of 5. We're starting at 0 and we only go up to 3 for the index. Note that you can't do the colon -1 syntax or anything similar. That's not allowed here to go in reverse. That's when you would use the reverse notation from before. We can also get the length of a string or an array or anything using the len keyword. If I say for I in 0 ... less than equal to the len of text. Now if I print the text at a position, that gives us the integer value of the ASCII value. If you want to have the letter again, you have to use the rune conversion. You can see now we have the letters again. Similar to other languages, Odin has the continue keyword when you're inside of a loop. So here we're going from 0 to 2 because it's in 3. When we run it, you can see we're skipping the number 32 in the output, pretty standard. And if you use break, then this is going to break out of this entire loop. So once we hit 32, then we're just going to skip back to this outer one. There we go, we go to 31 and then stop the inner loop. You might have seen this feature in some other languages like Java. You can name the loop. So I say this is the outer loop, then I can say continue and jump to the outer loop. So normally continue would jump back to the beginning of this block, but when you have continue and then a label for another spot, then it will jump out there. So when we run this, as you can see in this case, it's similar to the break output. But if I print here, you can see this never runs. Whereas if we had used the break keyword, then it does run. So if you want to skip all the code that's out here as well, you can use a labeled loop or break outer, for example. That will make everything just stop after only 2 iterations. So once we hit this, it's basically saying call break on the outer loop out here. Let's mark loops as done. Next up is enums. If you've used another language, you're probably familiar with these. Basically, we can have a type that only has a few distinct values. For example, let's say I have directions. We say colon enum, then we can specify what they are. Now I can use this as a type, so I can say current direction is directions.east, let's say. Let's go ahead and swap the switch statement up here because we're going to cover that right now. It's like match in some other languages. You can say switch, then over some values. So let's say my current direction. Then we use the case keyword. Now it knows I'm trying to talk about directions here, so I can just say dot, and then it would give me the autocomplete here to know I'm talking about a direction. Alternatively, you can say directions dot whatever. I'll stick with this syntax though. So if I'm facing east, then do the following code here. This is not like C where you have to use the break keyword after each one. So for example, I can say going east, then we can copy this for west. You'll notice I'm getting a syntax error here. It's because it knows this is an enum. It's like, hey, you didn't cover all the cases here. You only did east and west, but we still have north and south. So if you actually know you're only going to talk about these two, is one, you actually cover all the cases. So for example, I would have south and north here, and then change these appropriately. We can go ahead and run that. Yeah, it says going east, because that's the direction we're currently going. Yeah, if I don't have all of these, we can say hashtag partial. Now it stops complaining. And if I did happen to be going north or south, I can say case, and then not specify anything. This is like a default case. Must be going north or south. Still says east, but if I change to be going south, there we go. So normally you would want to actually cover all of your cases if you were using an enum here. So this is more of a niche case where you'd want to have the default case and partial. But you don't have to be using the enum in the switch case. Instead of using an enum, we can say like my grade, which is an int. For now, we'll just say it's 90. Now you can specify a range here. So I can say case 0 to less than or equal to 50, less than half. And it detects that I have a duplicate case here. So I can say at 51 up to 100. Even if I overlap to like 40, you can see it doesn't catch it in this case. If I was 45 here, then it, let's say less than half too. You can see it only hits the first case that works. But if this was 51 to 100 and I'm 55, you can see it hits the second case. So we can just call this like top half. You can also put more than one condition. For example, if we had some letter, I can say the case where it's from A dot dot M is one case, or I was also lowercase a to lowercase m. Whoops, we need the equal signs. And for the case statement, we use a colon, not a curly bracket. You were A to M, and then we can say capital N to Z and lowercase n to Z. So when I'm capital X, it says N to Z, and even if I was lowercase u, I'm still N to Z. But if I'm uppercase C, then it goes in this first range. That is enums and switch statements done. Next up, the defer keyword. If you've used Go, then they also have that there. Basically, you can say to run some code at the end of your function. For example, defer fmt.println. We'll just say A, B, C. And we say this will run first. So we're actually running this one first. We'll run second. It runs our normal code as normal, like going down in order. But everything that we deferred, then it goes in reverse order. So we ran CBA. Since we did C last, that's what ran first. It's like a stack. It's the last in, first out order. You can also defer blocks of code. For example, if I actually wanted to run this in the ABC order, we can use the curly brackets, and then I take out the defer word here. There we go. Now this whole block is run together instead of separately. Most commonly, you're going to use this when you have to do manual memory management. You can also combine the if statement with defer. For example, if I say x colon equals 5, then we can say defer if x mod 2 is 0. Remember, this is like checking the remainder. So since this is odd, this is false. So this will not get deferred currently. Currently, we're just going to run this bottom line. But if I say this is 4, then you can see we ran this. And then because this statement was true, this got deferred until the end. If the statement is false, then we just never run this code that's inside. Another cool thing with defer, it's based on the block scope. For example, I can just make a block of whatever here and it will run as normal. You can see it doesn't matter if I have an extra block, but if I have defer inside of here, it's going to run once it hits the end of this block. So defer. And if we run it, you can see we ran this as normal. But then once this block ended, we ran the defer statement, and then we ran the end of main as normal at the bottom. It's very powerful what you can do with defer. That is defer done. Let's look at procedures now. We've already been using a procedure the whole time. That's the main function. There's some extra cool things you can do with it. We'll say example function, remember colon, then the proc keyword. This is kind of similar to Jai syntax if you've seen that. I'm going to assume you already know what functions do. See, currently, if my main function is empty, this never runs. It's only once I call the function, putting the name and then parentheses, that we run it. Pretty standard. Generally, functions are used because they have parameters of some kind. We'll just say that this function adds some numbers. So you say the name of the variable, colon the type, so it's similar to when you declare it. If I have more than one variable of the same type, I can just combine these if I want. I'll show both ways. So I'm printing out a plus b here. We'll just do 4 and 7. And see, we have 11. Like I said, I can combine these because they're the same type. So I would just have a comma b, and it's the exact same as before. You can group as many as you want as long as they have the same type. If I had a different type after this, I'll just say a float value, f32. If I try to add this here, then we get an error because it's like, oh, you can't combine ints and floats. This a little bit ties into the next section. I can just make this an f32 if I wanted. Or instead of adding, we'll just print the float as well, 5.4. So it's adding the first two numbers and second one is just kind of there. Let's say I want to return the value of the function. I'll zoom this out a bit. We'll go back to just having a and b here. If you want to return a value, it's like every other language these days. You do the arrow syntax. If I say I'm returning an integer, I'll take out the float that I was providing before. See, currently I have an error because it's like, oh, you never returned a value. As usual, we use the return keyword, so I can just say return a plus b, and here we'll rename this to be or add ints. When we run that, you can see nothing happened because I never do anything with the value up here, so I can print it out and see we have 11. If you want, you can have named outputs as well. To do that, we wrap this in parentheses. I'm going to say we have a result :int, so it's kind of like nim syntax where by default you have a result variable. So I could say result equals that. Then I just have an empty return at the bottom, and it would still give the same answer, returning the result variable. Although it's not that clear in this case, so it's recommended to go ahead and put result, but I didn't have to declare the result variable. See, I don't have the colon. It declares it when you say that's what I'm going to output. Of course, things could get confusing if you had C, which is 7, I returned C. Then it's like, oh, you didn't actually use this result variable, so just be careful when you use this. So this is bad. This can be cool, though, when you have multiple return values. For example, if we have x and y, let's just say we're implementing the div mod function. Oh yeah, that's a default, so we'll call it div mod again. Basically, div mod is a built-in. It gives you the quotient and the remainder because it's the equivalent of these two functions. Answer from division and remainder. So we'll basically implement that down here. I can say x equals a divided by b, and then y is a modulo. Then we return x comma y. I'll go ahead and use this example that I said here. So 17 and 5, 3 and 2 as we expect. Or again, you could just not put that, but it's kind of bad practice. Or if we don't even want them to be named, we say int comma int, and then we say x comma y, and now we have to declare these. All different ways to do the same thing. We'll say that we're done with procedures, but we'll go ahead and tie that in down here with these two, the types and pointers. We've already looked at things like bool and int and like f32 or f64. There's like a lot of types here. Instead of null, what we have here is nil. So it's like Go or Lua. If you want to convert between types, say I32 to convert like 5.7. We'll say here, my int. This one we can't do because it's rounding. We can't pass in a float explicitly, like the literal value. But if I had my float and I say it's an f32 is 5.8, then I can say my float down here. We'll get rid of that. As with most languages, we round the float down when we convert it to int. So to convert, you just say the type and then parentheses, or you can do it this way. You can say my other int. You can use the cast keyword. Then I say the type in here, like I32, and then I can just say my float after that. This is kind of like that style in C or Java where you just put like int or whatever and then the type. It's similar to that. You can also just use the auto cast keyword, and that also works. So let's print all of these out. You can see here, since we didn't specify the type with autocast, it didn't know to convert it to an int. But if I had said here int, then it works fine. Now let's look at everyone's favorite pointers. This kind of ties into types, so we'll mark that done. I feel like the pointers are a lot simpler to use in Odin compared to, say, C or C++. Modify number. Say we pass in some int. To say it's a pointer type, use the caret symbol and then int. So it means a pointer to an integer. Then I can say some int plus equals 2. You can see we have this error here saying, wait, it's a pointer type, not integer. So to dereference it, so this is currently an address. To get the actual number value, you put the caret symbol on the right side. So you can think of it like reference when it's before and you dereference it when it's after. X colon equals 5. So you see it complains because this is an integer, but it wants a pointer to an integer. So to pass this as a value, which is an address, you use the and sign before. It's a little confusing when you first start, but it's basically when you're talking about the actual type, you put the caret symbol before. That gets you an address. To dereference the address, put the caret symbol after. Then to pass an address, use the and sign. So if I print X after this, you can see it got modified here. So normally if we had made this not be pointer at all, then yeah, it even tells me like, hey, this basically isn't doing anything. You can't assign to a procedure parameter. It's basically saying like you can't modify what comes in by default. If you actually wanted to, you could say colon equals 2. This is like redefining the variable, shadowing. Yeah, so if we actually did that and then said that the original 5 is not modified here, it's back to being pointers. It is modified, so it takes a little bit of getting used to, but this is really nice. You can choose if you want to pass something by pointer, which is also called by reference, because by default, everything is passed by value, so it's like a copy. Doing it this way also saves on memory, because like, when I say pass by copy, it has to make a copy, but if you use a pointer that's by reference, and it's like, oh, you don't have to make a whole ton more memory, an array of 100 elements doesn't have to copy that whole thing. You just say where that pointer already exists, use that. Maybe let's go ahead and tie this into arrays here and dynamic arrays. So first let's make a standard int array. We can show it more with pointers. So we'll have my array. If you just want to say I have like an empty array, you have to say how many elements it's going to have. So I'll say 5, and this is of ints. If we do it this way, as a 0 value, since this is ints, then they default to 0. If it was booleans, they default to false, and so on. Let's show the values in this array. We can just print that value. You can see it's all zeros. If you want to say what's in the array by default, here we'll just copy paste my array 2. So you can say colon equals that, and then we give curly brackets. Now I can specify what's in it. If I try to give more than that, then it's an error, because it's like, hey, you said you're going to give 5 values, but you gave 6. Let me take that one out. I'll comment this temporarily. So this should be my array 2. You can see it goes through it as normal. If you're going to define the literal array here, but you don't know how many you're going to type, you can put a question mark. But this is not the same as an array list or Python list. It's not the same because you can't add on to it later. That's a different data type that we'll get to. But so I can just type as many as I want here. But if I try to like say my array 2 at position like 124 equals 45, then it's able to detect like, hey, you only typed 8 numbers up here. So even though you put a question mark, it's like, I see you're putting 8, but index 124 is way out of bounds. So that's not allowed. We'll just go ahead and run it to show, yep, all the numbers printed out here. Yeah, let's look at how to mess with the array as a pointer. So we'll have a modify array, square brackets, int, since that's our type. In this case, since we know we have an array of length 8, we can specify 8 in here, and you want the pointer. So I could say sum array at position 2 equals 99, modify array, my array 2, and I have to pass it as a pointer, so we use the ampersand. So let's look at this now. You can see that worked. We have 99 in there. Well, let's say I don't know the length of this array. I want it to work with any size. Different syntax. We take out the number, but we leave the caret symbol. Now you see it's like, oh, this is expecting like any generic array, but you're giving one that's size 8 specifically. To get around that, we pass a slice. So this is not a copy, it's giving the actual memory address. So you do square brackets and then colon, and now we can put the ampersand. Let's make a modify array version 2. Oh, here we'll call this modify any array. This one up here was for fixed length. This one is any length array. So in this case, we take out the number that specified how much and the pointer, and the caret symbol. And here I'm going to change this one to be modify any array. So first let's start with this. It's like, oh, you have an array of size 8, but this one wants to work with any sized array. So it's telling us you can fix that by using the slice syntax. I use square brackets and then a colon. So this is a reference to this array. Remember, it's not a copy. So when we modify this here, we'll just change this to like 55 to make it more clear. We print it out. Then you can see we modified it, and then it stayed modified after that. It gave us 55. Remember, anytime you make a slice, that's a reference. You're not making a copy like you would in Python. Now let's look at structs here. At the top, we can make a struct. This is kind of like object-oriented programming, but not really because you can't attach methods. We'll just say that I have a person type struct. Now we say all the parameters that they have. So we'll just say that a person has a name, which is a string, and an age, which is an int. Let's go ahead and mark the pointer and array as done. So we'll have a variable Bob here, which is a person. So the syntax for this, use curly brackets after you say the name of the struct. If I just do this, then they have default values, like the name is the empty string and age is 0. We'll say that their name is Bob and age of 50. And as with most, so Odin isn't specifically an object-oriented language, but as with most object-oriented languages, you can get the values of those by saying bob.name and age here. We run that, it's Bob. We can specify that a function takes in a struct though. So I could say like change name, and this is supposed to take in some person, which is a person. If we just said some person dot name to be Johnny, you can see we get an error here because we can't do that unless it's a pointer. So let's change it. Say it's a pointer to a person. Notice we don't have to dereference here. When you do this dot syntax, it automatically does that for you. So like in C++, for example, you'd have to do like the arrow syntax. You don't have to do that here. It just automatically does that for you when you use dot, which is really nice. So if I run change name on Bob, and then we print their name again. Oops, so we got to pass it in as a pointer, or the address. So remember, that's the ampersand. Basically, inside the function is where you would use the caret symbol. Then outside of there is where you use the ampersand. Yep, so his name got changed to Johnny. Let's add a few other topics to cover, like dynamic arrays. And there's maps, which is like dictionary. So we'll mark structs as done. We'll have my expanding array. This is like the Python list or array list in some other languages. So this is called a dynamic array. You can make it by saying colon equals make in square brackets, dynamic, and then type. So whenever you use the word make, this is similar to C++. You have to manage the memory yourself. Since this is only in the main function, like this will get cleaned up when the program exits. But if you're making one of these inside of a function, then you have to make sure to delete that yourself. Otherwise, every time you call that function, you're just gonna keep using more and more memory, and your program will eventually use up like all the memory. So just be careful. To append onto these, we don't use the dot syntax for functions here. It's like you might expect you would do like my expanding array dot append, but you can see even though it autocompletes here, it's actually swapped around. So you're supposed to say append and then you give the address here. So let me just type that myself. Say append, what do I want to append onto? The address of my expanding array. And then I say what I want to add on to it. I want to add on, let's just say the number 5. Then we can print that out. And you can see it has 5 now. And I can add on some other things as well. And you can see 5, 3, 1. We can also pop from it. That's to remove elements. Or this removes from the end, rather. So if I just say my expanding array, and then here we'll just print it out again. Then you can see it was just 5 and 3 at the end. Like the 1 disappeared. Whenever we use this word make, we can use that defer word that we looked at earlier. So I want to delete my expanding array. You don't give this as a pointer here. You can see that's an error because it knows what you're trying to say. Again, because this is the main function, you don't actually have to do this because the program memory gets cleaned up when the program exits anyway. But if this was inside of another function, we would want to do that. Otherwise, you end up with memory leaks. You can see like nothing changes. Unordered remove. So you can remove from an array in O of 1 time, but this is like if you don't care about the order of things in your array. Basically, it's swapping whatever element you say to remove with the last element and decreasing by 1. So for example, I can say remove from my expanding array, then you say the position to remove. So I want to remove index 0. So normally if you did this in Python with like pop position 0, then everything has to shift back over. If we're doing this unordered remove, then it's swapping position 0 with the last element and then just doing a normal pop, which is always O of 1. So we would have to print this out again, or we just remove 4. So you can see it only prints out 3, and we can comment the first time we're printing out everything. Yeah, just the number 3. So now let's look at the slices here. So you can say S to alias it, but I'm not going to. I'll just say slice dot sort, and I can say to sort my expanding array. Oops, we don't need the pointer. Instead, we need to make this a slice. Let's add a few more things in here. So right before we sort, we can say add in like 99, 50, 70, 60. That's another thing. You can append more than one element at a time using append. So now if I copy, you can see it's all sorted. We have the 3 from above, and then 50, 60, 70, 99. Yeah, tons of functions inside of Slice. I'll let you look into those if you want. Let's move on to the last topic of maps. Similar to the dynamic array, you can use the make keyword. We say map, and then inside of here, we say what the key is. It's like the Python dictionary. It's like you're going from one value to another based on key value pairs. We'll say I'm going from string to integer. We'll call this name to age. I can say name to age at position John equals 30 and position Nick equals 50. Later on, if I want to say, wait, how old was Nick again? I can just say fmt.println name to age at position Nick. Make sure to use the same capitalization. You can see printed 50. If I want to see if someone's name is in there, I can, similar to Python, say if test in name to age, then we'll say test is not here if it was not found. So it's not there. But if I added it in up here, we'll just say they're like very old. Then we'll say test is here. You can also do this cool syntax here. We can say value, comma, existed, colon equals name to age at JKL, just random letters here. And then if we print this out, so this gives the value if it was in there, and then a boolean of true or false of if it even existed. So you can see the value was 0 because it's mapping to integer. It's the default value for that, which is integer, and false because it did not exist. And if you wanted, you can put this inside the if statement line. We can say if value comma existed is that, then we give the condition at the end here. So it's kind of like the walrus operator normally works in Python, except we're assigning some variables and then we use them later on in that line. Like this is the boolean that we're checking for the if statement. Did exist. We didn't get this printed out, but if I had put up here equals 777, and you can see it did exist. And again, because this is using the make keyword, you would want to defer and remove this. By default, you can see it uses the context.allocator. What that means, the whole program has a context variable, which gets used for different things. For example, the logger and random number generator. There's also this temporary allocator, which you can use. Of course, if you're returning your map at the end of a function, then you probably don't want to use the temp allocator. You have to manually clear this though, whenever you're done with it. So at the end of your program, you could always just say defer free all, because this is an allocator. Again, doesn't really matter here because this is the main function. It cleans up at the end of the program, but it's just good practice to do this. Another cool feature with the map and checking if something exists. Let's say the value is not found in there. Some nice syntactic sugar that we have is you can say or else. Then I have a default value provided here. Let's say if z is not found, which in this case it's not, I can say that their age is 80. Printing that out, you see since z was not found, we get 80. If I looked for x in here, because that does exist, we get that value. All right, with that, that is the Odin programming language. If you want to see some game dev with this in Raylib, let me know. Other than that, thanks for watching.